What do you count as general methods in combinatorics?
General methods, like they started to use linear algebra, that is for me one of the most striking and hard problems, and suddenly like this magically, so that is method already that you systematically
For extremal set theory or extremal, yeah.
almost your first thought is that now let's try linear algebra or linear programming or maybe semi-definite programming. So that was one area, at least to me actually, and also harmonical analysis. So harmonical analysis plays a big role, and then alone it's methods can be developed which are just it's a method in harmonical analysis or a method in combinatorics, one cannot tell. Maybe it's a method in both. At least in arithmetic combinatorics, this is the case. This is the narrow subject which I know better. And then you know in theoretical computer science is that then yes, there are also the linear algebra is extremely powerful.
So what about more elementary methods that, I mean, like combinatorialists would develop by combinatorial means, so the probabilistic method?
The probabilistic method is maybe the best example in both theoretical computer science and combinatories. And then maybe one of the striking problem is the problem of the Ramsey numbers.
Could you explain it?
Maybe. So it will be a little bit technical, but that was most probably the most striking example of using the so-called probabilistic method. At that time it was not method yet. It was just an idea, and it was Erdős' idea, though I have to tell that he was not the first one who used the probabilistic argument proving deterministic results. The Ramsey problem is the following, that you have a complete graph and you two-color it.
The edges.
The edges. You two-color the edges, and then you want to find a monochromatic subgraph, which means then the subset of the vertex set, so that every two vertices in that subset has the same color. Maybe all of them are red or all of them are blue. And then let's assume that you have a graph on n vertices, so how big is the largest monochromatic? And then this is a relatively easy proof, then it should be at least log n, but then maybe it is much bigger. And then came Erdős, Paul Erdős, who in the 40s just randomly two-colored, meaning then, okay, took an edge, flipped a coin, and with probably one half it was red and half it was blue. And then he proved that for most of these choices, of a sequence of choices, which will result in coloring, there is no bigger monochromatic subset that I don't know, I guess two times log n. Of course, still between log n and 2 log n there is a
between 2 log n and half log n.
Yes, half log n there is a gap, and this is one of the greatest unsolved problem in combinatorics, but definitely in graph theory, to close the gap. And then we really haven't made practically any progress in the last 50 years.